All right, everyone. Very good morning. And let's just start, okay, without any further delay. I hope my screen is visible to all, right? Pranesh, Shiva, Vinay, anyone can confirm? Yeah, okay, all right. All right, so we'll start with module one, and that is going to be the packet capture. Not packet capture, that is the packet processing. Means if you have to just process the packet with the Palo Alto Firewall, then what is the flow logic is going to be look like? What is the step-by-step packet forwarding is going to happen? So we'll try to understand the step-by-step packet forwarding, like packet flow logic for the Palo Alto Firewall. And then after we'll discuss about the single pass architecture. So we're starting the module one. This is a completely theory module. And in this module, we have the key focus on the just to understand the architecture of the firewall, along with that step-by-step packet processing of the firewall. All right. So let me find one of the document and then we'll start that. Give me 1 second. Somebody under the name of Acer. What's the name? Acer laptop might be join that. Can you just tell me your name?
Sir, my name is Purnavendran Das.
Okay. All right. Welcome to class, Purvander.
Yes, sir.
Okay, let me put you, Mr. Das, here in this group. All right. All right, guys. So this is the packet flow we have to understand today. This is the module one as per the official model. What is the packet flow? What is the step-by-step packet flow is going to be look like? And what is going to be happen if any packet is going to land in the Palo Alto firewall? That is our agenda, and we'll discuss on that. All right. Okay, so let me start.
Sir, is this the first class of Palo Alto?
Yeah, just we are starting the very first module. We have some basic discussion in the past as a demo and all. Okay,
Hmm.
but we are starting the module one today. Okay, we did this. I believe you joined the initial configuration, right? How to onboard the new firewalls. You there, right? Or not?
Yes, sir. Yes, sir. Yes,
Okay,
sir.
yeah. So that was already covered. Means if any new firewall you have, then how you're going to be onboard that new firewall. But here we are going to target from module one and we'll go sequentially for the all modules. So we are starting from the module one, that is single pass architecture and the parallel processing. Clear?
Okay, sir.
Okay. So the idea is, let's suppose you have any Palo Alto firewall. This is your PA01, and this firewall might be going to receive some packet from any client. This might be the PCA, and this want to communicate with any server S1, and they have different IP address. So the moment the packet is going to land, let's suppose the moment the packet is going to land from the PC to the Palo Alto firewall, this is the first flow, and from Palo Alto to the server, that is the second flow. So in between, till the time the packet is going to stay within the Palo Alto firewall, then what action Palo Alto is going to take? Means how much time the Palo Alto going to take the packet inside of this particular firewall, and what all action Palo Alto is going to take, how they are going to treat that packet. So that is what we are going to discuss in the packet flow. Means we have to understand in ingress stage what is going to happen. Means when the packet is going to hit an ingress stage, and when the packet is going to transmit, that is basically egress stage. You can see here. Then in between we have the multiple stage.
Sir, the packet is incoming packet or outgoing packet? It's any type of packet.
No, we are talking about outgoing packet have a different kind of the processing forwarding, incoming having a different. So generally that packet should receive by the Palo Alto firewall, and then how it is going to forward from the Palo Alto firewall. That is a one sequence we have to understand. Not because once we transmit the packet, there is no control on the Palo Alto firewall, right? So only the packet when it is going to receive by the Palo Alto firewall, that only have the control on the Palo Alto firewall to take some actions. So this is something when we are receiving the packet from any device to Palo Alto firewall, and then what I'm going to take an action inside the Palo Alto firewall means Palo Alto firewall is going to take action inside the firewall, and then how it is going to be transmit the packet from the Palo Alto firewall to the end destination. So it's incoming to outbound, not outbound to inbound. Outbound inbound is never going to be part of the Palo Alto firewall. It's always going to be incoming. You get my point or not?
So can we explain again?
Yeah. So let me use the whiteboard. Think about this is a Palo Alto firewall, right? There is a two device. This is a server S1, and now this is take as a S2. This is server 2. So what is going to happen? This server want to talk to this server. This is the one flow. So when these want to talk, your packet is going to be received on the Palo Alto firewall interface. So this is going to be inbound packet or outbound packet, Mr. Das?
Sir, it's a inbound for Palo Alto.
Yes. And when it is going to send from here to here, then
Outgoing.
so what I'm trying to say that if this server is trying to talk to this server, the packet is going to receive in the inbound, and then here your packet flow is going to be applied. So any packet coming from the in to out, once the packet is out, do you have any control on the Palo Alto firewall?
No, sir.
No. So out packet doesn't have any kind of significance to the packet flow. Now think about this server want to talk to this PC. So packet is going to receive on which interface? This interface. So this is going to act as an inbound packet or outbound packet?
Inbound packet.
Okay. And again on this interface.
Outgoing, sir.
So from this direction, again, your packet flow is going to happen. But again, it's an in to out. So always you have to think which interface I'm receiving the packet and where I'm going to send. The moment you receive the packet on the firewall interface, your packet flow start doing the inspection and they start doing some sort of the actions. Clear now?
Yes, sir. Clear.
So we have to understand the moment the packet is received by the Palo Alto firewall and before sending the out to the Palo Alto firewall, what all actions Palo Alto is going to take inside of the firewall. So interface where the packet is going to receive, this is known as the input. The interface the packet is going to be sent, it is known as the output. This is also known as the ingress. This is known as the egress. Egress means sending packet out. Ingress means receiving packet. Input means receiving packet. Out means sending packet. Or you can just think about receive packet or transmit packet. All meaning are going to be same. Clear? All meaning are going to be same. So if I'm going to use the word like input, output, you just think about I'm talking about the incoming packet, outgoing packet. If I'm taking name as an ingress, egress, think about I'm talking about the incoming packet, outgoing packet. Ingress is incoming, egress is outgoing. Receive is also incoming, and transmit is also outgoing. All right. Now back to again on the board, and we discuss about we have this packet. The packet is going to receive. After receiving this packet, how this packet is going to take an action, and based on that, they're going to transmit that we have to understand. So very first thing, whenever any packet is going to receive by the Palo Alto firewall, they are going to check, means in the ingress stage, they are going to perform some certain actions. And the action is they will verify what is their layer 2 address, layer 3 address, and layer 4 information. So they will verify and extract the layer 2, layer 3, and layer 4. So layer 2 is going to be your MAC address, layer 3 is going to be your IP address, and layer 4 is going to be your like port numbers. So these three information they are going to verify. And after verifying these three things, they will also check on which interface, means what is the interface name. So let's suppose your interface name is going to be ETH0 by 0. That is going to be interface name. Plus on the interface, what zone they have. So total how many informations? 1, 2, 3, 4, and 5. So you can see they are going to find what all the layer 2, layer 3, and layer 4 information have the packet. And after that, what zone they have on the packet means the interface, and then which interface the packet has been landed. Now, these all are self-explanatory. You know that what is a MAC address, what is IP address, what is the port number, and what is my Ethernet. But might be not about the zone. So you just note down zone is something very special in the Palo Alto firewall, and we have to learn about zone. So I will explain what is zone in later on. But for time being, just note this keyword. We have to must know about the zone, and zone is very important in the Palo Alto firewall.
Sir, sir, in the MAC address, sender MAC address and the receiver MAC address both will be checked by the Palo Alto firewall, and say as well as the in the L3, the IP, sender and receiver both.
Yeah, so in packet, whenever we're going to design the packet always going to combine multi informations. Means you have the source MAC, we
Yes,
have the
very good.
destination MAC, that is a layer 2, or we have the source IP address, we have the destination IP address, that is a layer 3, we have the source port, we have destination port, layer 4, then we have the application, and then you can mute yourself and some additional information, then we have the your payload. So this is the one packet format. So you're always going to check these all information whenever you're going to check the packet informations. Clear?
Yes, sir, clear.
Okay. So I will check that the all information. After checking that all information, the next step is it is going to verify the packet I received that is really actually fragmented packet, or it's a plain like a non-fragmented packet. So what is the fragmentations? Fragmentation is, let's suppose you have one of the switch and this is connected with a firewall. This firewall further connected with the router. So might be the switch is means every interface having some capacity to transfer the packet. Means size of the packet. By default, if you go and check on the any interface, MTU, maximum transmission unit is going to be 1500. So any interface by default going to transmit or receive the size of the packet is going to be 1500. But let's suppose you send the packet of the 3000 MTU side. Then what is going to happen? There's two options. Might be this interface is simply drop your packet, or the second option it is going to be fragment your packet. So what is fragmentation? Fragmentation is going to just divide this packet in two part and make this big packet into two packet. So 1500 into 2. So your packet is just divided into big packet to small packet. If let's suppose 6000 size of the packet. So they are going to divide the four part of the packet. Each is going to 1500, 1500, 1500, 1500. Let's suppose you have the packet size is a 6000. So fragmentation is a method where you are going to just simply divide the packet so that your interface is going to accept. So that's why if any case my PC is sending the larger packet toward the server, this interface is not going to receive more than the 1500 byte. So it will do the fragmentation if applicable. If lesser than 1500, definitely fragmentation is not needed. But if your packet is more than 1500, they will must do the fragmentations. So this all action they are going to take in the ingress stage. Then after the next step is once they are going to take these all actions, the next step they will check the packet which I received, they have any error or not. If error, after checking these all informations, if they found any error, your packet is right away drop in the ingress stage. Means firewall will never receive your packet. The packet having error, they will drop at this stage. It will never going inside of the firewall. So if they will know inside of the firewall, it will never going to receive on the server. Okay. So
Sir,
what are the
which type
10
of
days?
error, sir?
Wait, that. You'll get the answers, okay? Wait for a while. You'll get the answer. So what type of errors? Let me explain about that. So if I talk about errors, so error is a multiple type, and let me explain one by one errors. So if I go a little bit down on this particular documentations, so these are the errors. So if you have the mismatch of the Ethernet type and IP version. So let's suppose your Ethernet layer 2 packets headers are different and your IP version are also different. That then in that case they are going to be discard your packet. So your Ethernet type is not mismatch. Your IP version, like it's not like you're using the IPv4 in the PC and on the firewall you're using the IPv6. So in that case also your packet is going to be discarded. Any truncated IP address. Truncated IP address, that means let's suppose your IP should have the 32 bits, but you're sending some region only 28-bit packet, means of the IP address. So that's not valid IP address. In invalid IP address, the information is not correct. So that is also going to be discarded. Any IP protocol number should not have a zero. Means you must have to make sure the protocol number should not have to be zero. So they are going to be discard if there is a zero. Any packet TTL value, time to live value should not have a zero. If it is going to be zero, then it is going to be discarded. Because TTL is very important. If TTL is not going to be there, and your packet is never going to move from one hop to another hop. So you must have to set some TTL value to just travel the packet from one hop to other hop. Now we have the land attack and we have the ping of death. This is the DOS attack. This is also kind of a DOS attack, but this is ICMP DOS attack. This is the different kind of the other DOS attack. Means any kind of the attacks, DOS, DDoS attack is going to be happen. In that situations also, you're going to get the packet drop by the Palo Alto firewalls. If you want to understand what is the land attack and ping of death, see, so both are historical denial of service. As I mentioned that, but this ping of death is basically ICMP. See, this is the ping of death, basically ICMP based attack is going to happen. And land of attack, like basically it's kind of the transport layer DOS attack, which is going to happen. But both are DOS attack. So if you're going to find any kind of attack in any situations, your packet is definitely going to be dropped. So that is a land attack and DOS attack of your packet. Now, the Martin IP address is invalid IP address. Means not valid IP address, not a valid IP address. Then it will also drop. That is also very important thing. Any invalid IP address is going to be there. That is also going to be drop. So Martin IP address is again invalid IP address. IP checksum error is like definitely IP checksum is very important. Any IP checksum is going to fail and there is error that is also going to be detected. Means dropped by the Palo Alto firewall. So these are the regions, Mr. Das. Okay, you can take a note. Okay, and if any of this is going to match, your packet is going to be drop at this stage. So this is the known as a ingress error process. And this ingress error process is going to be processed, then your packet is going to be drop at this stage only. Clear, Mr. Das, now? And
Yes, sir.
everyone? Okay. Now moving forward, guys, we have the further means let's suppose everything is good here. My packet is good, my ingress stage is good. Now the next step is going to happen. It will check, do we really require the inspection? If the answer is yes, then it will go and check the next step. If the answer is no, your packet is actually transmitted to the destination side. You can see this is a big line. If your answer is going to be no here, just say, no, I don't want to do that inspection. You put it no here. Then a simple packet is going to be like this. And let me go down and see. It is going to like this way. And further it is going to be destination. So it's very important. Why? you should check this, because if you are going to apply the Palo Alto firewall, any other firewall, so you must have to apply the inspection. If you're not going to apply the inspection, your firewall is going to act as a just simple router and switch. Means layer 3 router or layer 3 switch. Means your packet is coming, and what they're checking? They're checking the MAC address and the IP address, and they send the packet. Again, this is also based on the MAC, based on the IP, they will check and they send the packet. So similarly, if you're going to apply the Palo Alto firewall and saying that, hey, Palo Alto firewall, you don't have to do any inspections. It will just check the MAC plus IP routing, and they will send the packet. So if you are going to apply your router and you don't want to do any kind of the advanced settings, you don't want to check any advanced thing, that is justifiable, because router having the just routing capabilities, and generally we do not do any kind of firewall things unless or until we are going to install the firewall module. Some Cisco router, they have the firewall module you can install, and you can do some sort of the firewall settings as well. But yes, generally router we use for the routing and switching. Basically, we can do the inter-VLAN routing, we can do the plain routing, BGP, USB, similar for the L3 switch as well. But for the firewall, we are going to pay extra, and the firewall not just only going to do the routing and switching. They can do routing and switching, definitely. Along with routing and switching, they can also do more about the firewall inspection. What is that inspection? That your content inspection, data inspection, vulnerability inspection, any kind of the policy enforcement, SL decryptions, all of things they can do that. So we must have to apply the inspection. There's no meaning to apply no, unless or until you have the very special use case. So you say, yes, we need to apply the inspection. And once we apply the inspection, the next step, it is going to check the packet you receive, that this packet is basically a VPN packet or non-VPN packet. Means the packet you're going to receive from the Palo Alto firewall, yeah, means the from any device to Palo Alto firewall, there is two conditions is going to happen. Might be the Palo Alto is going to be plain text packet. Taken this example, this is my Palo Alto firewall. This is the PA01. In between, let me use some other. Just take this is my PA01. This is connected with the any ISP. That is a internet. This is my PA02. And behind that, we have the LAN. This is my switch and one of the PC connected here. Behind that, also we have the LAN, PC connected here. So we are going to require in Palo Alto to build the VPN tunnel. This is the VPN IPsec. We'll discuss that, how IPsec is going to build. So we are going to build a VPN tunnel between these two locations. So what is going to happen? If any packet coming from this way, like this way, via VPN, it is going to be fully encrypted. Packet is going to be fully encrypted. So for this packet, the firewall will behave differently if this is a IPsec packet. But might be you are just trying to do the under reachability from this interface to this interface. You're not sending via the VPN. Take an example. You want to communicate via this to this. So this is not considered as a IPsec traffic, because this is going via the directly from the exit interface. In that case, your firewall is going to behave differently. Means what is going to do, what they're going to do, that they're going to do that some short of the considering as a plain text without encrypted traffic. So if your packet is coming as a VPN traffic for some reason, so the firewall first convert this packet into the plain text. So they have the dedicated engine on the Palo Alto firewall. Let's suppose this packet is going to reach here, and this is the IPsec. They will send again to the decryption engine in the ingress stage only, and again say, hey, can you just convert in the plain text so I can enforce my inspection, and then it will convert again, and then it will go again to the my ingress stage, and then again your all process is going to start. When this is the first sequence, this all first sequence. But now once it's going to, it's become a second sequence. Now in second time, this packet is in the plain text.
सर
Yes.
सर ऑलरेडी तो L2 L3 एंड L4 इंफॉर्मेशन हम लोगों को पता चल गया है, तो अभी वो एनक्रिप्टेड पैकेट है, तो डिक्रिप्शन करने के बाद फिर से वो सेकेंड स्टेप में क्यों जाएगा?
So that you'll get the answer. You might be not know in the IPsec in the CCNP in core NRC. If you have learned the IPsec, how the packet is going to be encrypted,
नो
decrypted,
सर, नो सर, नो सर.
that's why you're not able to. So generally what happen if you go in the IPsec, there is two mode, tunnel mode and transport mode, right? So let me show you. Give me 1 second. So you guys have to wait to understand. If you don't have any idea about the IPsec, I will teach this IPsec in later on, so you understand. But let me give the brief idea how things is going to be look like. And give me 1 second. Okay, we using the method in IPsec encapsulated security payload ESP. There is two mode, tunnel mode and transport mode. So if you are going to use the transport mode, your original IP header is going to be like unencrypted. Okay, so you are having the original IP header, but your data is going to be encrypted. So you must have to also check the data. Now, if it is going to encrypted, if any data having a malware, any kind of signature, then how are you going to understand? So you must have to do the decryption for data. Now another method, if you are going to use a tunnel mode, then your original IP header is also going to be encrypted and data is also going to be encrypted. So for that, you know, adding the new header. So you find this new header IP address, but your still original IP is hidden. So this is going to be only visible if you're going to apply the read decryptions. So thus you will understand later on. Okay.
ओके सर, ओके सर.
Once I'll explain. So the packet is going to be again in the your IPsec tunnel interface. Means this is going to be again as a plain text, and then after your packet is going to land in the fast path. So the next step, your packet is going to be come from here and they're going to land in the fast path. And when it's going to land in the fast path, this is going to check. Means again, let me draw here the PC. This is my firewall, Palo Alto. This is my server. So let's say everything is good. Then a packet land here, and after that, it is going in the fast path. So now we have a two term. One is a fast path, one is a slow path. So what is a fast path and what is a slow path? We have to understand about that as well. So if I talk about the fast path is a path if you have any existing sessions that all session are going to be stored in the fast path. Means any existing sessions means a very first time you communicating with the firewall, this firewall doesn't have any session. So very first time you are going to access this any kind of the connectivity to the server, they don't have any session. So in that situation, your session will not found in the fast path. It will go from fast path to slow path. Means any new connection. Again, I'm repeating. Very first time you are communicating to the any firewall. Means from any device to any other device via the firewall, your communication are going to be happen, but your session will create at that time. And that is a new session. And that new session will very first time not available in the your fast path. It is going to be created by the slow path, and then it is going to be again stored in the fast path. But when you're going to again second time reach to the Palo Alto firewall for any communication, it will never going to check the slow path. It will just find the session in the fast path. So let me again repeat that all statement, what I'm just giving that. I'm saying that, let me put it here. This is your Palo Alto firewall, right? This is my brand new device, PC. This is my brand new device server. If this PC want to communicate this server, very first time, so there is just fast path. Fast path is going to store only existing sessions. Okay, fast path is going to store only existing sessions, means any session is available, and if packet is going to land in the fast path, it will go into process. But if any new session is going to be reached, means very first time your packet is going to land in the Palo Alto firewall, there is no new session, no new session. So they will help to create the session. And who is going to create the session? Once your packet is going to land in the fast path, they will check, do you have a session? If the answer is yes, I have existing session, they will go again layer 2 to layer 4 processing. If answer is saying no, you don't have a session, you will move in the slow path. So slow path is basically to help to, it will help to create a new session. This is my slow path. If any existing session I have, I will simply process from here to here. But if there is no new sessions, means existing session is not available, I need to get a new session, it will go in the slow path. So slow path is a path, it will help to create session for the new packets. Fast path is a path where if I have the existing sessions, it will simply going to process from the L2, L4, L3 and other like application identification, content identifications, and the SL decryptions. Now, let's assume I have the very new packet. I don't have any session available in my Palo Alto firewall. Definitely, my packet will come here and will go here. Then what information the slow path is going to check? The slow path is going to check three information. Very first information, their routing. Very first thing they will check, the packet I am receiving does have routing. If the answer is yes, I have a routing, then they will check the NAT policy if applicable. It's not necessary all packet require the NAT. No, if you have the internal to internal communication, might be you not require the NAT. But if you have the internal to external, definitely you require the NAT. So it will check the NAT policy lookup as well. Then they will check for the final thing, security policy lookup. And then they will check if all is going to match, then they will create a new session. And after creating a new session, they are going to install this session in my fast path, right? Means the session is going to be installed here, session is going to find in the fast path. So they are going to install the session. And if the same packet again going to become, then this time it will never going to be in the slow path, it will simply go here. But if in this stage, any of these is going to find, this not going to find, my this not going to find, my this not going to find, or all not going to find, your packet is going to be discarded at this slow path. It will never going to be in the fast path. Make sense? So slow path is a path where we are going to create a new session. Fast path is a path where if any existing session is going to be there, based on that existing session, the packet processing is going to happen. So in short, you have to remember if very first time any device is going to communicate to any other device or server or any destinations, always packet is going to be in slow path because they're not having the any existing sessions. But if they already communicated in the past, they have the existing sessions, and based on that existing sessions, they will stay in the fast path and they will process the packet. They will not go in the slow path. And it's not like, let's suppose today 8 a.m. you did the communications. And now let's suppose next 10 hour you're not doing the communication. So your session is not going to be always available in the fast path. No, there is a session timeout also. So for TCP sessions, 3600 seconds. So if there is no communication for next 3600 seconds, you can calculate in hours as well. I believe it's 60 minutes it's going to be happen. So next 1 hour or 3600 seconds, it's not going to be communicate any kind of the communication. Your session is going to be removed from the fast path And when again you're going to start doing communication from 600 seconds, after 30 seconds, you are again going to be create a new session by help of the slow path. Any questions? Pranesh, Shiva, Vinay, Anthony, Das, Ravi. Any questions, guys? Till here?
सर स्लो पाथ एंड फास्ट पाथ तो समझ गया हूँ सर, मगर उसके अंदर में स्लो पाथ के अंदर में थोड़ा सा वो डिस्क्राइब कर देंगे और एक बार, फॉरवर्डिंग लुकअप, नेट पॉलिसी लुकअप,
So
फायरवॉल
this is just a routing, okay? So
हम्म
this is just routing. It is going to check the routing information. This is the routing informations. This is the NAT check, and that is the policy check. So always, whenever the packet is going to reach in the slow path, the very first thing routing is going to be checked. Second thing, they are going to check the NAT policy. Third thing is going to be checked as the firewall security policy. So these three things is going to be checked, and then they will process the packet. Anthony, Pranesh, Shiva, Vinay, what about you guys? It's clear till here? Okay, Vinay is fine. Pranesh, Shiva.
Yeah, it's okay, sir.
All right, good. Thank you, guys.
Yeah,
So
it's
now
fine,
let
sir.
me move. All right, thank you. Now moving further, let's suppose now we understand the slow path and fast path. Now let's suppose the packet is landing in the fast path. Means any existing packet landing in the fast path. So what they're going to do that in the fast path? So in fast path, they will first match the session. If session is going to match, definitely the session is going to match if it is available. They will do all things. Like if NAT is applicable, session is there. So everything, whatever you have done here, based on that, your session is created, and then your NAT is going to be checked out. Now, after that, they will check the packet which I receive. Does this packet require the SSL decryption? Now, might be you're going to think about what is SSL decryption. So we'll discuss later on. This is a part of one of the module in our course content. I will show you later. Let me show you. So don't worry about that. See, whatever you're seeing in the packet flow, so decryption is there, application identification is there, content identification is there. And these all are in the, say, application identification, content inspection, application. So you're going to get in the packet flow application checks, content checks, and the SL decryptions. And these are a dedicated topic available in our course. But in packet flow, we're discussing very high level to get understanding what all checks is going to be happen. But in later on, we'll see the detailed understanding about each of the concepts while doing the labs, right? So let me let me explain these things today, okay? And later on again, when going to be touch the module, I'll back again here, I'll re-explain here. So if you're not going to fully understand, it's okay, no problem. It's happened for the everyone. So if the packet is going to be there, they are going to check, do we require the SSL decryption? So what is the SSL decryption? One is the IPsec encryption decryption, and one is the SSL. So IPsec is different technology, SSL is different technologies. SL is secure socket layer, that is known as also TLS, transport layer security. So if any packet you are doing to do the communication on the HTTPS, any website, these are completely secure encrypted packet. So if you want to see if the packet having any kind of the malware, any kind of the virus, any kind of the vulnerability, so you must have to decrypt this packet because it's encrypted. And you want to decrypt this packet, then you have to require the SSL decryptions. And then it is going to check whether this packet having any kind of the malware, any kind of the virus, any kind of the vulnerability, any kind of bad content, any kind of DLP and all. So sometime it is required. So if required, we will do that. If no, we can ignore it. So let's suppose it's required. Then it will ask inside the applications, what means inside this particular sessions after decryption, what applications they are trying to access. So might be trying to access Facebook applications, Yahoo applications, Gmail applications. But in some case, might be firewall is not able to recognize. If it is recognized, then it will go and check the content inspections. But let's suppose you are accessing some internal application, company application, some unknown application. Firewall doesn't have that information. In that case, they will send you special engine, and that is the special engine is going to known as the application identification engine. You can see here. If let's suppose for some reason your application is not identified here, for some reason, so it will send your packet to the application engine. And there is a one term, it will check. Sometime what we say in the Palo Alto Firewall, hey, you don't have to do any kind of the application check. Let me log in one of the Palo Alto Firewall. I will show you. And that is known as the application override. So you see here, and we go in the policies and see. This is the application override policy. See, this is application override policy. So why we create the application override policy? Sometime intentionally, we do not want to check the applications. We want to bypass to check the applications. So in that case, definitely your application identification is not going to happen. So you are definitely bypassing. So you can see it's showing the yes, you bypassing. Then you're going to check that other things rule like layer 4 inspection. They're going to check that IP and address, and based on that, they will say whether you have to allow or deny. If it is saying okay, you have to allow without application check, your packet is going to be allowed. If you say no, it's not ready now, it need to be denied, it is going to be denied. So this is the your application override. Application override is basically you don't want to explicitly check the packet should be match for the application or do the checks for the applications. But you say no, 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 it's not enabled. Application override is not enabled. Then what is the next step? You say no, it's not enabled. Yes, then it is going to be like this policy lookup and then actions. It's allow or deny. But you say no, it's not applicable. Then it will try to check the based on the AI ML pattern based check. Whatever the application I found as an unknown application, new application, I don't have the database. What is the pattern? And does it matching in my any scenario based pattern? Means any kind of the pattern which is already have a database, or it will try to check. Let's suppose take an example, somebody having some digit, okay, and by looking at the all report, you're not able to find what this digit is. Means might be you check the blood test, might be you check other test, but you're not able to find what basically this digit. But you're just trying to understand the like symptoms of the your patient. Might be he having pain in the stomach, but his report is saying that everything is good in the stomach. So probably based on the symptoms, you're going to give the medicines. Okay, let's try. His stomach having a pain, so I will give some painkiller for the stomach. So probably after taking this medicine, he is going to be good, or might be not going to be good. But so basically, what is going to happen in the Palo Alto Firewall? It will try to check the signatures, and after checking the signature, it will try to check what is the pattern of the signatures. And if they found, if everything is matching with the some particular signature symptoms, based on that, they will take an actions whether packet need to be allowed or deny. So this is what is going to happen in the application identification. Means application is going to match, then it's okay. No extra checks is going to happen. But it is not going to match, then they will do all the checks, and then after that your packet is going to process. So here this all, and then it's going to again content inspections. So if they, let's suppose this packet is not required here, application identification, it direct landing their packet in the application identification is going to happen. Then you're going to check the content. Content is what? Actual your payload. Means your actual payload, actual data. Means any actual file, any kind of the Word file, any PDF file, any kind of email attachment, any kind of text attachment, anything you're sending and receiving from your source destination. That all content is going to be inspected. And based on the content, sometimes you say, no, I don't require the content inspection. Then it is going to bypass. It will simply transmit your packet. But it's saying, no, no, I need to require the content inspection. And how we basically apply these content inspections? If you want to apply the content inspection for the Palo Alto Firewall, you always have to go in the policies under the policy, you have to find this all options profile. You can see antivirus, vulnerability, we have the anti-spyware, URL filtering, file blocking, data filtering, wildfire analysis. So these all are different kind of the actions that is used for the content inspections. Applications we go and apply here, right? URL services are going to be here, but content are here. So if you say no, it's saying that none. So that means you do not require the content inspections. But you're saying yes, it is required, and you apply this policy, then it will start doing the checks. So same thing we are talking about that content inspection. Might be you're going to say no, I don't need it. So it is going to be simply bypass your packet and it will going to be transmit your packet. But you're saying no, I require the content inspection. So once you apply the content inspections, right, then it is going to check all the detail. Means it will check the virus, it will check the vulnerability, it will check the everything, whatever you want to apply here. And based on that, it will take an actions. Means you're saying if any anti-spyware activity is going to happen, what action I want to take. Any URL filtering is going to happen, then what action I want to take. So you are going to define some actions. I want to block, I want to allow, I want to deny. So based on that actions, they are going to take an action in the your security policy. So you can see there are a lot of action, reset, both, default, or even you can deny. If you're getting a new one, you're going to find option as a action as a deny drop as well. So whatever action you're going to do that, based on that, even you're saying no, I want to just get the alerts. So you're going to get an alert. So you can see this is going to be protocol parsing, decoding, content matching, tunnel application detections. Means everything they are going to be checks, and after that, if it will check. Sometime what happen, even while accessing any website, any URL, any applications, your content might be going to be changed. Let's take an example. If you're accessing the one of the Facebook, here you use the Facebook applications, okay? And it say Facebook is allowed. But your Facebook chat is blocked for the organizations. Facebook chat is blocked for the organization, but Facebook page is open. So in applications, Facebook is one applications, Facebook chat is another applications. Let me show you in the Palo Alto file directly so you can understand the better way. If you go in the application and search in the Facebook. See, so Facebook is one application, Facebook base. Facebook chat is another applications. Facebook games is other applications. Facebook posting is another applications. You're uploading, downloading. These all are the different applications we have. In these all applications, if you say I want to only allow the Facebook, but suddenly you go in the chat is blocked. So what happened in the Palo Alto? If application change from the content inspection, while checking that content, they found that hey, you change the applications, and in that situations, might be it is going to be say yes, then it is going to check the further policy security lookup. Does this new application is allowed or not? If say it is allowed, then it is going to be yes. That it is not allowed, then it is going to be no. It's very important. Even your content is getting changed, and based on that, they identify different application you are trying start using. So firewall is very intelligent. They will find that, and based on that, they are going to take actions. Now further, they will check that any like kind of the detection results. You want to allow alert. Means once you apply the security profiles, you have to send the alerts, send the sessions, set sessions, discard, and then finally, if let's suppose you say like everything is good, no need to drop anything, then before sending the egress stage, your packet is going to re-encrypt because you decrypted here. So now again you have to re-encrypt. Why you decrypted? Because you want to make sure you want to verify the HTTPS traffic. You read for the HTTPS traffic. So it's very encrypted. Now you have to convert in the plain text. And again, when you convert the plain text, again you have to make the HTTPS traffic here. And once you make the HTTPS traffic, you must have to process traffic in the ingress stage. And now again you can see before you send the packet in the egress process, now in very upper side you decrypted the your IPsec packet. So before sending this out, you must have to encrypt the packet, because in the very top place, we decrypted this packet. See? So this also one decryption we do for the SSL, but before that we did for the tunnel. So tunnel is going to in last. SSL is going to be decrypted here, decrypt to encrypt here. Then second is going to be your IPsec is going to be there. Then it is going to be again encrypted, and then it's going to be processed. If you're plain text, then it's fine. Definitely it is going to be similarly in this way. Clear till here? Questions, please ask me questions if you have anyone.
Sir, pattern-based application identification.
Pattern based application. You not understand?
Yes, sir. That's particular line. What is the pattern-based application?
Uh, in this particular slide you are asking or something else?
No, sir. From in the green box, this application right side green box
Okay,
pattern.
pattern based. Okay, this okay. So pattern based, right? As I mentioned that, let's suppose your application is not identified for some reason. Your application is not identified. So what is going to happen? There's two actions going to happen. Might be you intentionally not want to check the application. For that, you have to create the application override policy. Okay, so that is one thing. I will explain what is application override policy. So then in that case, you really don't want to check the application. You want to check, you want to bypass the application. But let's suppose you say, no, I don't want to bypass Office, but still your firewall don't have any informations. So they will check the pattern of the applications. Pattern is basically symptom of the application, signature of the applications. As I give the example, let's suppose you have some problem. You have some stomach problem and you go for the doctor given some test, let's do some blood test, let's do some ultrasound and all, and everything is looking as a normal, but still you have the pain. Then doctor what will do that, they will ask your symptoms, and based on that symptom they will give some medicines, right? So might be you have the pain, like pain in the stomach, so they will give some medicine for the stomach. It might be you're going to be fit or might be not going to be fit, so further investigation is going to happen. Similarly, it's just example, not take seriously for the Palo Alto. Palo Alto, what is? Let's suppose any application not match in their database, and also you not have the bypass policy for that application, then they are going to check the application identification based on the pattern, based on their signature. So every applications, they have the predefined signatures. If we go here, let's suppose this application. So every application they have a signatures, right? It's average save application, excessive bandwidth is going to take or not. And you can see a lot of information, TCP timeout value, you can see standard port, what they are using, depending on. So they have the database in their database. This database is going to use for the application, or might be if you're creating any kind of the custom applications, you also have to define the signatures. You can see here, so you have to give the signatures, which applications I have and what kind of the context they have and what kind of the pattern they have. So based on that context and pattern, I will show you when I'll talk about the application identification, how to create the custom applications and how to set the context, how to set the pattern, then you're going to get better understanding. And if it is going to be match, then they will take some actions. If it is not going to match, definitely it will simply allow. But if it's going to match, no, this pattern which I find right now, it's not good, it's a bad pattern. So they will simply deny, because might be come as a category of the virus, malware, or some kind of the bad URL, bad application, social networking application that is not allowed from your organizations. Okay, Das?
Yes, sir.
All right. Any other questions? Anthony, Pranesh, Shiva, Ravi, and Vinay?
No, I'm good. So basically, there are two type of encryptions are happening whenever a user is sending the traffic, right? So one is happening at the layer 7 SSL, and the other is at the layer 3 IPsec, correct?
Yes, one is IPsec. It's a very beginning stage. IPsec is going to be encrypt your entire packet. And there's two option. IPsec use a two-level encryption. One is the only for the payload. Okay. and your headers are going to be free. So that is known as a transport mode. Another is the tunnel mode, where your original header and the data is also going to be encrypted. So in that case, they will add the new header. So either of they means when you're going to configure the IPsec, you have to select transport mode you want to configure or tunnel mode you want to configure. So very first thing, they're going to do the decryption for the IPsec packets. And second thing, this is the HTTPS packets. So you don't have to use the word layer 7. You have to use the encryption method IPsec or HTTPS SL encryption. They are two different things. Both are the layer 7 because the packet having all informations.
Okay.
Okay, Vinay?
Uh, and so let's say if the interviewer asks us to explain the traffic flow, so like the packet flow, we have like lot of terms and this and that. So
Mm-hmm.
how we are going to explain like this much? Because maybe we get
Yeah.
forget.
Yeah, definitely. It's a very fair question. So say this all must be you have to recall in your mind. Okay, entire flow you have to just keep in your mind, and entire syllabus of the Palo Alto depend on this packet flow. Means for the every sections, whatever I'm going to configure and test, they all are going to relate to the packet flow. So simple answer, two, three things you also always have to remember. One is the must ask question, what is the difference between slow path and the fast path? What is slow path? What is the fast path? So you should know a key difference. Slow path is basically to create a session. Used to create a session, any packet landing in my firewall, and I don't have any kind of session. So slow path used to create a sessions, and they will check the three parameters: routing, NAT policy, and the firewall security policy.
Yeah,
If these all are going to match, they will create a session. But if there is a new session already means created, and again I'm coming to the for new communication, I have the session, then this packet will never go into slow path. So that is a slow path is never going to come in a picture. Your fast path itself is going to be used to just make sure you have the packet processing directly by checking the existing sessions, and then they will check the your SL decryptions, and they will check that application identification and the content inspection. Only four things is going to be checks. Your layer 2, layer 3, layer 4, your applications, layer 7, and decryption is required, that all, and content. That packet, generally we have these all informations. Now, these box, you just have to keep in your mind why we're using the content. You're going to get this idea once I'll discuss the dedicated topic. So you have the application and this decryptions. But initially, if you're having good understanding about a slow path, fast path, and then what is happening in the ingress stage, I believe that is good. And later once we'll discuss this all content inspection, application identification, I believe you guys will get better understanding in later on. Okay,
okay,
Vinay?
sir. Yeah,
But
and
it's going to be in memory based on your practice only. So yes, definitely you have to just take a print of this document. I will save it that and try to put in front of your study room or might be the office. So you can always keep an eyes wall box.
sure, sir. And sir, one last question. So where does the concept of IPS and IDS fall in this firewall? Do we have that in here?
Yes, yes, we have that, and this is actually your IPS and IDS is the content inspection.
Okay,
So this is going to be your IPS and IDS. This entire module, or you can just think about IDPS and IDS. Means basically IPS and IDS, intrusion prevention system
prevention.
and detection system. So what is intrusion? This is all antivirus, spyware, vulnerability. These all are DOS. These are all common intrusions. So IPS, IDS, there is no dedicated module. This is a next generation firewall, and this next generation firewall live in the Palo Alto, Checkpoint, and FortiGate. You're not going to find dedicated IPS, IDS modules, but they are inbuilt and they have the feature to just inspect your entire traffic and take an action on that.
Okay, yeah, thank you, sir.
All right, Binay, Anthony, Pranesh, any questions? Siva, Ravi? Okay, so if there's no questions, so I'm not going to talk this SP3 architecture today. We'll start class tomorrow on the same time, and we'll continue with the single pass architectures with the parallel processing. So tomorrow we'll discuss these all things and we'll continue further configuration part. So tomorrow we'll discuss 30 minutes this SP3 architecture. Then I will start doing the configuration part, some lab discussion and all. So you guys will get more better understanding how to configure, how to troubleshoot the Palo Alto Firewall. So thank you guys. Have a great day further. See you again tomorrow. Bye bye. Take care.